My name is Venkatrao Gummadi, Professor in the Department of Civil Engineering. Subject name is Hydrology and Irrigation Engineering. The role of irrigation engineer is not only collection and supply of water to the irrigation, they should know about occurrence of water. In this regard, we are all civil engineers. We should know about occurrence. For that, we should learn hydrology. What is hydrology? What are the component parts of hydrologic cycle? What is hydrologic cycle? Hydrology is the science which deals with the occurrence, distribution and movement of water on the earth's surface. It includes in the atmosphere and below the ground surface. The water in the atmosphere is in the form of vapor, whereas above the ground surface the water is in the form of water as well as snow, whereas in the below the ground surface as a groundwater occupying all the voids of the geological formation. These forms of water is essential, where we are going to discuss about groundwater hydrology, where we are going to discuss about evaporation, transpiration and another hydrological components. Next one, what is hydrologic cycle? Hydrologic cycle is the process in which the water transfer from atmosphere to the earth surface and evaporation to the back into the atmosphere. It is simply known as Earth's water circulatory system is nothing but a hydrologic cycle. The phenomena of hydrologic cycle or the mechanism of hydrologic cycle as shown in figure. This is the groundwater surface having undulations because groundwater is not in the plane way. So this is the groundwater surface. Here, this is the precipitation or rainfall. Once the rainfall falling over the ground surface, a part of water is infiltrates into the ground surface and remaining part of water moves above the ground surface. First of all, we are going to discuss about infiltrated water. This infiltrated water then percolates down and touches to the groundwater table. Once the water touches the groundwater table, this will always try to move downward direction. So here one depression available, that is nothing but a lake. So this groundwater, because of gravity, moves towards the downward direction, that is towards the lake. Here having one term here, that is the spring. Springs are formed in some cases, that are also not formed in some other cases. Where the springs are formed, this is depends upon the geology of the existing strata. Where the existing strata is confined aquifer, that means two impervious layers, that is the infiltrated water is somewhere that flows below the ground surface in between two impervious layers that will create some pressure. This pressure also creates some problem because of that is also nothing but pipe water flow. In generally, pipe water flow having some additional pressure apart from the atmospheric pressure. Once this confined aquifer flows in between two impervious layers, therefore here form a spring. And then where the aquifer is the unconfined aquifer, that means one side impervious layer and another side exposed to atmosphere, that means open. In that particular case, the water flows towards the downward direction because of only gravity. There is no spring formation. Right here in the lake having some water, this water exposed to atmosphere, because this is evaporation takes place. The surface of the lake water evaporation takes place, as well as here having some plants. Plants also taking some evaporation. Strictly speaking, this is not evaporation, this is the transpiration. Right? Again, water also evaporates through the rivers and also evaporates through the ocean. So here, once this evaporated water, here condensation takes place and also transfers into precipitation or rainfall. Again this rainfall touches to the ground surface and evaporates up and down. This is nothing but a hydrologic cycle. Based on this figure, the major component parts of hydrologic cycle is, one is evaporation and also transpiration, and another component part is precipitation or rainfall, and the next component part is the runoff. Runoff means, so a part of, this is the precipitation or rainfall, a part of precipitation percolates down and a part of water flows above the ground surface. This is nothing but runoff. Evaporation and transpiration. Evaporation means the water evaporates from the ground surface as well as moist soil. Whereas in case of transpiration, transpiration is the process in which the water being lost from the leaves of the plants and their pores. The evaporation and transpiration is also known as evapotranspiration. Here the evaporation having different forms. Surface evaporation, that is the evaporation from the ground surface, whereas another one is the water surface evaporation, evaporation from the rivers and streams. And another evaporation takes place plants. This is also nothing but transpiration. And last one is the atmospheric evaporation. And precipitation. Precipitation may be defined as fall of moisture from atmosphere to the earth's surface in any form. That may be water form, that may be liquid form or snow form. Basically the precipitation may be two forms, that is one liquid form, another one is the frozen form. The moisture falls to the ground surface in the form of precipitation. A part of precipitation may be evaporated through ground surface and water bodies, and also from the lakes and rivers, and also from the plants. A part of precipitation, the remaining part of precipitation is available as a runoff that may be reached to the surface and subsurface that ultimately reaches to streams. The runoff may be classified as three types. One is surface runoff, subsurface runoff, and groundwater flow. Surface runoff means once the rainfall touches the ground surface, a part of water flows above the ground surface, that is known as surface runoff, and part of water infiltrates down, that is subsurface runoff. That surface runoff flows above the ground surface and ultimately reaches to the nearest streams and rivers. Once the water touches the ground surface, a part of water infiltrates down and moves in the ground surface as a subsurface flow. This ultimately reaches to the oceans and rivers. And last classification is the groundwater flow. This is also part of precipitation. Once rainfall touches the ground surface, a part of water infiltrates, then that percolates down and touches the groundwater table. This groundwater table forming a reservoir, this water is also finally reaches to the oceans. And next topic is measurement of rainfall. Before going to learn measurement of rainfall, we should know what is the necessity of measurement of rainfall. Here, the rainfall is the major source of water used for various purposes. Knowledge of rainfall quantity, intensity of rainfall, and the distribution of rainfall is extremely useful for the irrigation engineer. Here, the amount of rainfall is measured in centimeters by using the rain gauges, and also the intensity rainfall is referred by using the units, that is centimeter per hour. Types of rain gauges. Rain gauges mainly classified as automatic rain gauges and non-automatic rain gauges. Non-automatic rain gauges are the gauges that are used for the rainfall. but these are automatically not operated. This is automatical rain gauges are recording type rain gauges. There is no automatically measuring mechanism in case of non-automatic rain gauges. In case of automatic rain gauges that are taken rainfall intensity as well as rainfall depth by automatically. And also the automatic rain gauges are classified as 4 or 3 types. One is white bucket type rain gauge and a tipping bucket rain gauge, and last one is the floating type rain gauge. Site selection for the rain gauges. The rain gauges should be installed on a plain areas, and the rain gauge should be located in such a way that the 2 times the away from the nearest objective height. And the rain gauge should not be provided side and top of the hills. And advantages of recording type rain gauges over the non-recording type rain gauges. Here, rainfall is recorded automatically, hence no attender is required in case of automatic rain gauges. And by using the automatic rain gauge records, the intensity of rainfall is measured, whereas in case of non-automatic rain gauges, only we can measure rainfall depth, that is in centimeters. And rainfall is recorded automatically, that is it can be placed anywhere in accessible points also. And another advantage is human errors are avoided because there is no attender required for the operation of this automatic rain gauges. So these are the advantages of automatic rain gauges as compared with the non-automatic rain gauges, but only drawback is the initial cost is high in case of automatic rain gauges as compared with the non-automatic rain gauges. Next one, optimum number of rain gauges. So optimum number of rain gauges are must to analyze to design the hydraulic structures on a particular area. For that, the optimum number of rain gauges is depends on coefficient of variation of the mean annual rainfall value at the existing station and available gauge error. So this is the definition. Based on that, we are going to estimate the optimum number of rain gauges. Once we know the optimum number of rain gauges, already we know the existing number of rain gauges. The optimum number of rain gauges and existing number of rain gauges, we should have the additional number of rain gauges required on a particular catchment area. The optimum number of rain gauges formula is M. This is denoted by M is equal to CV by E whole square. CV is the coefficient of variation, E is the available gauge error. And also we have one more formula, CV equal to sigma divided by P bar. Sigma is the standard deviation. This is also having one formula, that is square root of sigma P minus P bar. Here P is the precipitation, that is different rain gauge stations, and P bar is the average rainfall, divided by N is the number of existing rain gauges, and minus 1. This is the formula for the determination of standard deviation. And P bar, you know, that is average annual rainfall over the catchment area. This is sum of the rainfalls on entire rain gauges divided by number of rain gauge stations, where N is the number of existing rain gauge stations, sigma P is equal to sum of rainfall on all rain gauges. And finally, the additional rain gauges required equal to M minus N. M is the optimum number of rain gauges, N is the existing number of rain gauges. Then we have the additional requirement of rain gauges on a particular catchment area. Then we are going to solve one problem here. Determine the optimum number of rain gauges in a catchment area from the following data. Here they have given number of existing rain gauges. Existing rain gauges are 8 and mean annual rainfall of different rain gauge locations. That is one rain gauge location 1000, another rain gauge location 950, 900, 850, 800, 700, 600 and 400. So these are the rain gauges existing on a particular area. That means 1, 2, 3, 4, 5, 6, 7, 8. 8 rain gauges are existing on a particular area. Now we are going to estimate the optimum number of rain gauges required. If these 8 rain gauges are sufficient, okay, there is no problem. After calculating all these hence, then we are going to finalize the number of rain gauges required on a particular area. Then here also they have given permissible error, that is 6%. Right. So we know the formula, that is first we are going to backward calculations here. So actual that the optimum number of rain gauges is equal to, this is the formula. You know, for this now you should calculate the CV value. CV is equal to, this is the formula. And also sigma is equal standard deviation. For the calculation of standard deviation, you should know the P bar. P bar is the based on the given data. Based on the given data, you sum all these heads divided by number of rain gauge stations. You have the P bar. Then standard deviation is equal to P. Means each rain gauge station value. Each rain gauge station rainfall value minus P bar. Already you calculated by using sum of the rain gauge stations divided by number of rain gauge stations. Then you go to, once you know the standard deviation, go to determination of CV. CV is equal to, already you calculated this one. Finally you have to determine the optimum number of rain gauge stations. Once you are calculating the optimum number of rain gauges is 19, the existing rain gauges already they have given that is 8. The number of additional rain gauges required on a particular catchment area is 11.